At noon on the 26th of November 2005, the peace and tranquility of the Vale of Llangollen was shattered by the It marked the start of a reenactment of events 200 years earlier, when the Pontcysyllte aqueduct was formally opened. Despite frequent heavy showers, a procession of canal boats made its way along the 1,000-foot-long structure, and as each barge reached the end of the aqueduct, it was greeted by a fusillade from the soldiers of the 41st Regiment of Foot. The aqueduct had taken 10 years to build, and its innovative cast-iron trough is supported some 125 feet above the River Dee by 18 massive stone pillars. At the opening 200 years ago, excitement was high. Never before had such a long and high aqueduct been built. It was meant to be the jewel in the crown of the Ellesmere Canal Company, and although the initial hopes of investors had developed into a sense of pride in its construction, all was not quite as it seemed. There was no doubting the breathtaking height and length of the structure. The crowds cheered for its success, but few would have realised that, magnificent though it was, Pontcysyllte no longer stood on the main line of the canal, or that its imposing size and elegant design was stimulated by the extremes of disastrous flooding on the one hand and by a shortage of water on the other. And no one could have foreseen that the aqueduct would not reach its true potential until Britain's waterways were given over to leisure interests more than a century and a half later. Plans for a canal to link the Severn, the Dee and the Mersey were unveiled at a meeting in the Royal Oak Hotel in Ellesmere in August 1791. Two routes were suggested. Both were branches to Whitchurch, to the limestone quarries at Llanymynech, and to the coalfields around Wrexham and Rwabon. Enthusiasm brought in £1 million in subscription applications during the course of the morning, and the Ellesmere Canal Company was formed to pursue the proposals. In due course, they appointed William Jessup to be their engineer. Although a modest and retiring man, he was a greatly respected engineer, and had much experience of promoting canal bills before Parliament. In his first survey, he favoured the technically more challenging westerly route. It better served the coalfields and was, as Jessup confidently stated, the best adapted to the accommodation of the country with coal and lime, and to the general commercial interests of the public. Jessup's argument was sound enough to win the approval of the committee, although they urged him to rethink the route to avoid a tunnel and to reduce costs. In the short period before the plan was submitted for parliamentary approval, economies included lowering the height of the proposed crossing of the River Dee and adding a staircase of locks to reach a higher summit level on the shoulder of the hill as an alternative to tunnelling through it. The Act of Parliament approving the plan was passed by the House of Lords on the 30th of April 1793. In truth, Jessup's choice was really a nice idea. Even in its revised form, it would cost 3 times as much as the eastern alternative, and would involve the construction of a 400-acre reservoir near Wrexham to ensure an abundant supply of water for the dozens of locks that would be needed to lift boats from the Cheshire Plain to the edge of the Welsh Mountains. Building canals was all the rage in the closing years of the 18th century and acted as a magnet to many young and ambitious engineers. Among them was Thomas Telford. At 30 years of age, he was already a skilled master mason, and had moved to Shrewsbury to refurbish the castle for the town's MP, William Pulteney. Telford's activities soon began to diversify into architecture and civil engineering, and subsequently, as a result of Pulteney's patronage and lobbying, he was engaged to make extensive alterations to the town's prison, and was also appointed Surveyor of Public Works. But Telford found the attraction of canal building irresistible, even though it was dominated by older and more experienced men like Jessup, now regarded as the premier engineer of the day. He was involved with many canal schemes in the East Midlands, and had been appointed chief engineer to the Grand Junction Canal linking London with the industrial Midlands. With such a heavy workload, it was his practice to delegate routine tasks, and in particular he now needed a resident engineer to take charge of the day-to-day activities and construction on the Ellesmere. Telford's chance had come. More intensive lobbying by Pulteney secured the post for Telford, much to the chagrin of Jessop's followers. With the title of chief agent and engineer to the company, Telford had achieved his objective, and had joined the select group of canal engineers. As well as supervising the contractors digging the canal, he was responsible for the detailed plans of buildings and structures to be erected on the canal, although all were subject to Jessop's formal approval in his capacity as chief engineer. In 1795, after days of torrential rain, the River Severn and many of its tributaries burst their banks. Acres of farmland were flooded, but paradoxically the disaster was to make a contribution to the elegance of Pontcysyllte. At Longden-on-Tern, the ferocity of the floodwaters had washed away the foundations of a masonry aqueduct being built to take the Shrewsbury Canal over the river. Telford was asked to survey the damage, and as a result of his diligent report, was invited to become engineer to the company. Their board of directors included William Reynolds, one of several industrialists from the ironworking area of Coalbrookdale in Shropshire. His contacts with other ironmakers had brought him knowledge of a short aqueduct being built of iron in South Wales, and he suggested this idea could be used at Longden. His offer to design one was accepted by the board and was completed within the year. Later, it would be inspirational in the final design for Pontcysyllte. On the Ellesmere, with Telford taking care of the day-to-day details, Jessop was able to consider wider problems. Water supply and crossing the Dee Valley were top of his list. The current plan was to cross the valley with a narrow, three-arched aqueduct at a height of about 100 feet, and have massive earthworks to support flights of locks down to it on each side. Boatmen were likely to complain the locks delayed their journey, but more importantly, the extra locks added to the problem of water supply, up to 60,000 gallons every time a lock was used. Even without this demand, ensuring an adequate supply of water for the whole canal was a daunting challenge. The canal company had their headquarters at Beach House in Ellesmere. The circular boardroom on the first floor had views along their canal in all directions. At its first meeting of 1794, the board, anxious to push ahead with building more of their canal, decided to extend the branch to the limeworks at Llanymynech, and also to begin work on the route towards Shrewsbury. Both required more locks, and created an immediate demand for more water. By now, Jessop had engineered several canals. He had learned much about the difficulties of canal tunnelling as compared to those of adding locks, and had also become extremely cautious when assessing the amount of water needed to keep a canal properly supplied. On the Ellesmere, he faced an acute shortage and needed every drop he could obtain. His current plans included a 400-acre reservoir north of Wrexham to supply both the present sections of the canal and the Rowabon section when it was built. Added to a potential supply of water to be taken from the River Dee, it was hoped this would meet the expected demand. Llyn Tegid acts as a natural reservoir and regulates the flow of water in the River Dee. If Jessop was to take up to 12 million gallons a day for canal use, the level of the lake would have to be raised to increase its capacity, so that in times of drought an adequate flow in the river could be assured. Also, taking water from the Dee would mean that Pontcysyllte would have to be built to the full height of 125 feet. Embarrassingly for Jessop, this meant he had to reverse the advice he'd given only 2 years earlier. After some indecision, the Canal Board finally agreed to the new plans, and in doing so, they committed the company to building what would ultimately become the spectacular structure acclaimed today. Agreement with the landowners to raise the level of Llyn Tegid was eventually obtained, and construction work began on a low dam across the outflow. A horseshoe weir was built near Llangollen to tap the river's flow, and, fortunately for today's leisure interests, the water was fed through a canal that was wide enough to be navigable all the way to the high-level aqueduct and its connection to the main system. The foundation stone for the first pillar of the original low-level aqueduct had been laid some years earlier, but further work had been suspended as part of an economy drive. Britain was at war with Napoleon in Europe, and inflation was beginning to bite at home. Any building work could only proceed as revenue from canal dues trickled in. The company decided work on the nearby aqueduct at Chirk should have priority over Pontcysyllte. In the event, this was to be a fortuitous decision, for it gave time for Jessup and Telford to refine the design for Pontcysyllte. Although building the aqueduct to the full height would mean the approach locks with their massive earthworks would not be needed, using the original masonry design would result in extremely heavy pressure on the foundations. Fortunately, growing confidence in the use of cast iron as a constructional material and the increasing skills of Telford's masons meant a cast iron trough, inspired by the one at Longdon, and carried on slender pillars, could be used to take the waterway high above the valley. The ugly and massive earthworks could also be replaced by more pillars and ironwork, and the upper section of the pillars themselves made hollow to reduce their weight. At this stage, the pillars had already been built to the string course 100 feet above the D, so the ironwork had to be made to fit, with cast iron arches supporting the iron trough. The components were cast by William Hazeldine at his ironworks established nearby at Plask and Aston, and were erected with such care that only one life was lost. 10 years after laying the foundation stone, Pontcysyllte was finished. It was a breathtaking structure, and opened with due ceremony on the 26th of November 1805. But Britain's economy was slowing, and trading had become fiercely competitive even before building work on the pillars had started. Coal from mines in the Midlands could be delivered more cheaply via the Chester Canal, and meant Ellesmere's northern section via Waben would not be profitable. With some relief, the company decided to abandon plans for this route, and with it went the necessity for the 2.5-mile tunnel, the alternative flight of locks, and also the nearby 400-acre reservoir, any of which could have strained company finances to the point of bankruptcy. Instead, the Whitchurch branch was extended to Hurleston near Nantwich, and made a junction with the Chester Canal. Eventually, the two companies merged their interests to become the Ellesmere and Chester Canal Company. The aqueduct at Pontcysyllte was still needed to carry water from the Dee to the rest of the canal system, but it would now be part of a branch rather than be on the main line of the canal. Abandonment of the Ravent section of the canal meant the northern arm could be terminated in the Trevor Basin. Tramways were constructed to serve the local brickworks and also to take the products of the nearby chemical factory down to the canal for shipment. Today, part of their route can be seen alongside the wharves where barges once loaded and supplies for local farmers were delivered. Like all of Britain's waterways, the canal is now given over to leisure interests and has been rebranded the Llangollen. Holiday barges now occupy the basin area, waiting for next season's customers, many of whom joined in the day of reenactments and celebrations to mark the aqueduct's 200th birthday. As darkness began to fall, the event was brought to a fitting and traditional conclusion with a spectacular display of fireworks.